Hello everyone. Today we're going to continue with solving equations. This time we're solving equations with rational numbers. So, our lesson question, how can you solve linear equations that include rational numbers? Well, there are three main steps, right? We can see them right here. The first one is identify the lowest common denominator in fractions. Combine our like terms with rational number coefficients and use the properties of equality with rational numbers. So these three things are all things we've done before, right? Now we're just putting it all together to solve our linear equations. So words to know. The reciprocal, if you remember, the other word or words for reciprocal is the multiplicative inverse, right? And the reciprocal is going to be, if we have a fraction, say we have 5 over 2, the reciprocal is going to be 2 over 5. So the one that best answers will be B, a number that when multiplied by another number results in 1, right? That's going to be 10 over 10, which is just 1. Okay? Actually, let me get rid of that circle. Now the coefficient. So a coefficient is a number that multiplies a variable. It's always this number next to our letter. Okay, so it is D. The lowest common denominator, or the LCD, is the smallest expression in which all the denominators of a set of rational expressions divide with no remainder. Constant, right? A constant is a number that does not change. It remains the same. It is consistent. It is constant. An irrational number is a number that can be written in the form of p over q, where p and q are integers and q does not equal 0. Basically, it's just a number that you can write as a fraction, okay? If we remember all of our irrational numbers, you can't put them into a fraction form, which is why they are irrational. So moving on, we have rational number operations. This should be familiar to us all, right? This is just adding two fractions with a different denominator. So for addition and subtraction, we need to find the common denominator. That is your first step. Step 1 is to find the common denominator. So if we have the numbers 3 and 5, right, there's nothing that I can multiply by 3 that'll equal 5. 3 times 1 is 3, 3 times 2 is 6, and that's over, right? I can't go backwards and multiply something by 5 and get to 3. So in this case, what I end up having to do is just multiplying my denominator. So 3 times 5 is 15, which is why the least common denominator is 15. Now, if you remember what you do to the top, you do to the bottom. So multiply the numerator and denominator by 5. And then for the second one, you have to multiply it by 3. So that's 2 times 5 and 3 times 5 plus 3 times, oh, I guess we'll go ahead and just write it as 15. So we can stay consistent with what they filled in. 2 times 5 is 10, 3 times 3 is 9, and then I'm just going to add them. 10 plus 9 is going to be 19 over 15. Or, yes, we write it as a mixed number. The closest 15 can get to 19 without going over is times 1. I keep my denominator, and then I do 19 minus 15, and that gives me 4. Right, so you see that they are the same answers. Now for multiplication. To multiply two fractions, multiply straight across. Remember, you do not do your crossing, right? If there is a multiplication sign, you go straight across. If there were an equal sign between the two, that is when you cross. But we do not when regular multiplying. Okay, so that gives us 6 over 28. We can simplify this by dividing by 2. 6 divided by 2 is just 3, and 28, we worked it out on the side here, divided by 2 is going to give me 14. So 3/14. Okay, now the last one, division of 1/4 divided by 2. So this is our keep, change, flip, right? Your KCF or KFC, whatever you want to call it. This is I keep my original fraction. I change my sign from division to multiplication. And you have to remember that whenever we have a whole number, it's really a fraction over 1. So I'm flipping these two numbers, which is going to give me 1/2. Right, I go ahead and do my regular, let me fill it in here. I do my regular multiplication. That's going to be 1. 4 times 2 is 8. So 1/8. And that's it. Right? This should all just be reminders. This is something you guys should be pretty familiar with. Now solve equations with decimal numbers. So rational numbers such as decimals often occur as both constants and coefficients in linear equations. So we have a couple of examples here, right? Here in our first one, we have 17.2d minus 24 equals 62. So just like we had to do before, I need to move this 24 out of here because it does not have the letter, the variable. So I'm going to add 24 to both sides, right? Because a plus 24 minus 24 is going to give me a 0. Right? So I can cancel that out. I can do my work 62 plus 24 on the side. And that's going to give me 17.2d equals 86. Okay? Now again, this is a multiplication, so I have to do the opposite. Right? Only by the number. Remember, you don't want to touch the decimal. The decimal stays exactly where it is. So if I plug it into my calculator, 86 divided by 17.2 is going to give me 5. Okay, now I have the same thing. This one has a little bit more of the steps worked out. This one I have to do my distributive property. Okay, so I have to distribute that they did right here. See how they break it down. You don't have to do it this way. If it's easier, please do. So we have that now. Now it's the same steps. We see here, once we do the multiplication, now we're basically at the same step, the same point, right? I have to do my opposite of the number that does not have the variable. I go ahead and do that. That's going to give me 45. And then I have to once again divide by just the number. And it's actually, when I plug it into my calculator, negative 3.6. So remember that this one is going to be negative because you're dividing and there's only one negative sign here. This one is a positive. Okay, if there's only one negative and you're dividing or multiplying, you are going to keep it as a negative. Okay? The next one is solving equations with decimals using the distributive property. So we kind of already went over that. the best example is using money though, which we can see here. Jerry's lawn service charges an initial fee of $4.50 plus $3 an hour. If she is asked to start before 7 a.m., Jerry charges 1.5 times the regular amount. If she made 29 and 25 cents on a job that began at 5 a.m., how many hours did Jerry work? So the number of hours that Jerry worked is going to be shown with the H. So we have 1.5, and then, so actually here's the start of our equation, right? So they tell me it is 3 hours, or $3 an hour, right? Plus her base, which is $4.50. And then it's going to tell me that she also charged 1.5 extra, right? Because she started before 7 a.m. So that's all going to equal to $29.25. So now I'm going to go ahead and distribute the 1.5. I'm going to write in my 3H. When I do the multiplication, I'm going to get these new answers, right? So they put this box here and it's kind of tricking you because it's just going to be the answer, right? Nothing has changed here, $29.25. Now I'm back to my same steps. Get rid of the number without the variable. Cancels out. I'm going to do the subtraction and now I have 22.5. Once again, that's multiplication, so I do my opposite and divide. 22.5 divided by 4.5, I plug it into my calculator, it's just going to equal 5. Okay, it's nothing crazy, it's same steps we've been doing, just maybe a little extra, including decimals or fractions, right? It's not as neat as the whole numbers. Still, nothing too complicated. Okay, got a little stuck there. Now the next is verifying the solution, right? Remember, this is always the most important step. You always want to double check. If you had gotten a negative number, right? You have to look back and think, well, I went ahead and we were talking about hours that she worked. Now, can we have negative time? Your answer should be no, so something went wrong, okay? Always double check. You can kind of look at your answer and compare it to the question and what they're asking. And if you see that something doesn't add up, you know you went wrong somewhere, okay? Otherwise, you want to plug it back in. So we determined that she worked 5 hours. So wherever I had H before, I'm now going to plug in a 5. So that's only in the first part, the 3 times H. So 3 times 5. Everything else stays the same. 4.5. When I add 4.5 to 15, that's going to give me 19.5. And when I multiply 19.5 by 1.5, it gives me $29.25. So since this is a balanced equation, our answer of 5 hours is correct. Okay? That's all you do. You just plug it in, check it. If it works, that's your answer. All right? So the next part is using fractions. I know this is our favorite part, but it's not so terrible, okay? So rational numbers such as fractions often occur as both constants and coefficients in linear equations. Z plus 7/9 equals 5/6. So we're going to go ahead and do the same steps, right? My number over here without the variable is the 7/9, so I have to subtract it. Now, unfortunately, I have to use and find my lowest common denominator, okay? Now, in this case, I can do 9 times 6, but there is actually a number that is smaller, right? So if I were to go 19, actually, not 19, 9. Your best bet is you want to do 6 and 9, and you want to list the first few factors, right? So I'm going to do 6 times 1 is 6, 12, times 3 is 18, times 4, 24, times 5, 30. And we'll leave it there for now. Now I have 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45. So I can compare. Well, that doesn't work out, right? 9 and 6 are not the same. 12 and 18, no, but hold on a second. I can see that both of them have 18. So 18 is actually going to be my lowest common denominator. Could I have used just 9 times 6, which was 9 times 6 is 54? Of course. But then I would have had to go through the process of simplifying everything. So I'm just going to make my life simpler. Do the 18, right? So that's going to be 7 ninths and 5 sixths. And I'm going to want to fix it so that, let me put them in the other way, right? Because it's 5 sixths minus 7 ninths. I need to get to 18, so that's 9 times 2, 7 times 2. And for 6, that's times 3 times 3. Okay, so 5 times 3 is 15 over 18 minus 7 times 4 is 14 over 18. So I kind of jumped ahead, right, because this is them doing this breakdown. So this, they already went ahead over here and did times 2, times 3, times 3. And now I'm going to write in my times 3, which was 15 over 18. Now I subtract and it gives me 1 over 18. And that's it. Okay? Now this next one. Use the reciprocal to solve for t. My first steps are the same, right? I get rid of this one over by subtracting by the opposite, right? So that would give me 0. I need to change the lowest common denominator. In this case is 10. So I would multiply this by 2, right, like they do right here. That's going to give me 2 over 10, which when I do the subtraction, 9 minus 2 is 7. Now, I need to multiply the reciprocal. Remember, the reciprocal is I'm just flipping these numbers. So 7 over 3. Why? Because this is going to be 7 times 3 is 21. 7 times 3 is 21. Any number over itself is always 1. Now I do the same. I have to multiply. 7 times 7 is 49. And 10 times 3 is 30. Okay? You can leave it at that. I'm pretty sure I mentioned to you guys, you can just leave it as the improper unless the answers that you are seeing are mixed numbers. Then you'd have to change it, right? So, if we wanted to do that, the highest 30 can be multiplied to go to 49 without going over is going to just be 1, right? I keep my 30 at the bottom, and then I do 49 minus 30, which is just going to be 19. And that's the same thing as the mixed number. Okay? Now, solving real-world problems involving fractions. So when it started snowing Saturday, 2.5 inches of snow were already on the ground. It showed at a rate of 1/4 inch per hour. After the storm, 4 3/8 inches of snow were on the ground. If no snow melted during the storm, how many hours did it snow? Let h represent the number of hours. Okay? Write an equation involving h to model the situation. So I had my first, right? I take my trusty highlighter. So I know that when it started, 2.5 inches were already there. Okay, it snowed at a rate. So if you ever see the word rate, that's usually going to be your number that has the variable. That's usually your coefficient. Okay, after the storm, 4 3/8 inches of snow were on the ground. Okay, so now I can go ahead and figure this out. Well, I have the 1/4 out of the way. Now 2.5 was already there. So it's going to be added to that 1/4 because my total after the storm is going to be 4 3/8. Okay, write the mixed numbers in proper fractions. This is a very important step. Please do not try and solve all this work using the mixed numbers, okay? You want to do it in improper, it'll make your life much easier. So if you remember, to change a number from a mixed to an improper, you need to multiply the denominator. So 2 times 2 is 4. And then you are going to add the numerator, which is 5. So 5 halves, right? Now I do the same thing with 4 3/8. 4 times 8 plus 3, and that's going to give me 35, right? That's 4 times 8 is 32, plus 3 is 35. Excuse me. 35 over 8. Okay? Then again, same steps. I'm going to do the subtraction. Now 8 is actually my lowest common denominator, so I just need to change the 5 halves. Okay? To do that, I need to multiply both top and the bottom by 4, right? We're at this step now. When I do that, I'm getting what? 5 times 4 is 20. 2 times 4 is 8. Now when I do the subtraction, 35 minus 20, that's just going to give me 15. But I'm not done yet. Remember, I need to still find what that h is. So I need to multiply both sides of the reciprocal to isolate the variable. Basically saying, to get that h by itself, I need to do the opposite of whatever this is and get rid of it. So I'm going to multiply by 4 over 1. When I do that, I do my multiplication. That's going to give me 4 over 4, which again is just 1. So I have what? On the other side of the equal sign, I have 4 over 1 times 15/8. I can go ahead and do this work. That's going to give me 4 times 15 is going to be 60. Now I can simplify, right? So the greatest common multiple that I'm going to use is 4. So I'm going to divide both by 4. That's going to give me 15 halves, okay? Then they change it into the mixed number. So a good indicator is if they give you a mixed number in the question, most likely they're going to ask for a mixed number at the end. If they don't, then don't worry, leave it as the improper. So 2 goes into 15 how many times without going over? That's 7. 2 times 7 is 14. So 15 minus 14 is 1. So 7 1/2. Right? And that's the exact same thing they got. Okay, so it's not difficult. It's just a lot of steps that we have to remember. Okay, now we're going to go ahead and plug that back into our equation and see if it works. So we're going to leave it as the improper, right? We're going to go ahead and skip a step and we're going to leave it at the improper. So 15 halves, right? Because as you can see, we went ahead and we changed that back to an improper anyway. And we changed the 4 3/8, which we said was 35/8. Okay? Again, I need to get the same denominator so that I can add these up. So again, it's still 8. So I multiply by 4. 5 times 4 is 20. 2 times 4 is 8. I add them up and I end up with 35 over 8. So is the answer correct? Yes. Simple enough. Right? Now another one. Alex needed 2 3/4 gallons of yellow paint to paint his living room and 3/4 of a gallon of yellow paint for his bathroom. He also needed a new paintbrush that cost $6. If he paid $62 for the paint and paintbrush, how much did the paint cost per gallon? Let X equal the cost of the paint per gallon. Okay, so let me take my highlighter. 2 3/4 gallons of yellow paint and 3/4 gallon of yellow paint. Paintbrush that cost $6 and he paid $62. So the paintbrush cost does not change, right? It doesn't, you know, if you go to the Home Depot and you buy paint, it depends on the size that you get, the quality of paint you get, a bunch of different things. Paintbrush is always going to be $6, okay, if it's that brand. So we're looking here. X is the cost of paint per gallon. So I'm going to actually have two numbers with the variable. Why? Because I have two numbers with the word gallon right next to it. So there we go. That is my second answer. Now I can go ahead and combine these. I'm going to change this into my improper, right? So 2 times 4 is 8 plus 3. It's 11, right? So 11 over 4x. Now with that said, I can combine my like terms. Both of these numbers have x's, right? So 13. So 11 plus 3 is going to give me 14 over 4x plus 6 equals, and it's still $62. We haven't changed the pricing yet. We haven't done any changing. Okay? Now that I have only one term with a variable, now I need to get rid of this 6. So I need to do the opposite of the addition, which is the subtraction. I subtract both sides, and that gives me 14/4 x equals 56. Now this is time for my reciprocal, right? So notice that even though the number doesn't have a 1 at the bottom, it's still the same thing. You're still going to do 14 over 4. You're going to flip it and multiply it to both sides. Remember, what you do to one side, you do to the other always. Okay? So now I can go ahead and this is going to equal 1. So I can just, remember, my 1 is invisible. I don't have to write it. And then I'm going to do my multiplying across, which gives me 224, right? If I had my calculator, or if you're just going to do it on your own, 6 times 4 is 24. 4 times 5 is 20, plus 2, 22. So I can simplify that to 16. So the paint costs $16 per gallon. Okay? So, again, same steps, same thing. If I were to go back and plug it in, I'm going to leave it at my 11/4 times 16 plus 3/4 times 16 plus 6 should equal 62. Okay, now I can simplify. Remember, you don't have to do it this way. This is just a quick check, right? So 11 times 4 is 44. 3 times 4 is 12. If you guys remember and like to use this shortcut, that's what I'm doing. I'm just dividing 16 by 4 and getting through this a little faster. Okay, so 44 plus 12 is going to equal 56 plus another 6, and it's going to give me 62. So 62 equals 62, and that checks out, right? It works. So how can you solve linear equations that include rational numbers? So linear equations that include rational numbers can be solved by finding the least common denominator, combining like terms, and using the properties of equality. So basically everything we've already done, just now put together to solve these types of equations. There is one last announcement I want to make, and that is that this week, right, this week we have our iReady testing. You have all week to complete this. Please take your time. This is placement for next year, for when you go to high school. Okay? Do not just rush through it. Do not cheat. You're only going to hurt yourself. So because we have the diagnostic, there is no Zoom meeting tomorrow. No Zoom meeting Monday. We may have one on Friday. I haven't decided, but for sure, we do not have one tomorrow. Okay? So with that, happy studying, guys.